In today's class, we talked about this stoichiometry, really stoichiometry. And stoichiometry, again, is when you predict amounts, this could be moles or grams, from balanced equations. And this balanced idea here is huge, because if these mole ratios are off, everything's probably going to be off. So we're predicting amounts from balanced equations using mole ratios. Now, there's three types of equations or problems I think we're going to encounter. So the first is when we're given moles and we're asked to find out moles. Whenever we're going from moles to moles of one substance to moles of another, it's going to be a one-step problem, one conversion factor, and you're just going to use the balanced equation ratios. For instance, let's say we had that equation A plus 2B makes 3C and 4D. These are just made up substances, elements, or compounds. So if we were given 1.4 moles of A and asked for how many moles of C there are, we would just multiply by the mole ratio, knowing that there are 3 moles of C per 1 mole of A. Now, the second type of problem was going from grams to moles, or moles to grams. If we're going from grams to moles or moles to grams, this is always going to be a two-step problem, two conversion factors. We're going to use the balanced equation ratios always, and then we're going to use one of the molar masses. Now, I think to answer which one do we use is always focusing on the canceling of units. So for instance, if we were given 10 grams of A and asked for how many moles of B there are, we would start by using the periodic table molar mass for A to cancel out grams of A. And then we would use the balanced equation ratios. For every 2 moles of B, we have 1 mole of A. Now, the other way, if we're given moles of C and asked for grams of D, then we're going to have to start with the balanced equation ratios and know that there's 4 moles of D per 3 moles of C, and then multiply by the periodic table molar mass of D, x grams of D per 1 mole of D. Now, the third type of problem we're going to be faced with is going from grams to grams. So this is when we're going to have a 3-step problem, and we're always going to use the balanced equation ratios and both molar masses. So for instance, if I gave you 125 grams of C, how many grams of A would we need? Remember, we can go from any one substance as long as the equation is balanced to any other substance. So we would use the periodic table molar mass of the unknown of the known first. Then we would multiply by the balanced equation ratios. And then finally, we would multiply by the molar mass of the unknown substance. So let's look at some practice problems here. I'm going to work on those on the side also. When propane is burned in gas grills, it reacts with oxygen in the air to produce carbon dioxide in water. I hope we're starting to realize that when we have CH something reacting with oxygen gas, we're always going to be making CO2 in water. So most important thing is to balance this. We have 3 carbons on the left. Let's make sure we have 3 carbons on the right. We have 4 hydrogens on the left on the reactant side. Let's make sure we have 8 on the reactant side. Let's make sure we have 8 on the product side. And now 3 times 2 is 6, plus 4 is 10. So that means we have 5 oxygens on the reactant side. Now for part B, it said if we have 100 grams of propane, how many grams of oxygen would also react? So this is a grams to gram problem. This means it's going to be 3 steps. So we're going to start with the molar mass of the known. So 1 mole of C3H8 is 44.11 grams. Let's use the balanced equation ratios next, and this looks like if nothing's there, we have a 1. So for every 1 mole of C3H8, it will react with 5 moles, so 5 there, of O2. And then let's end with the periodic table molar mass of the unknown value. So I think 1 mole of O2 is about 32 grams of O2. So now we take 100, we divide it by 44.11, we multiply it by 5, then we multiply it by 32, and we get 362.7 grams of oxygen. And again, I have 4 sig figs here because I was given 4 in my starting value. So for C, if we have 25.0 moles of propane, how many grams of CO2 would be produced? In the day and age of global warming, we have a lot of calculations like this to predict how much carbon dioxide is being produced. So we're going from moles to grams. I know this is going to be a 2-step problem. So first, since I'm going to grams, I know that I'm going to use the molar mass of that that unknown substance second. So I'm going to start off by turning C3H8 into CO2. That's looking at those balanced equation ratios. And I know that for every 1 mole of propane, I'm going to produce 3 moles of carbon dioxide. Again, we put the value that we're trying to cancel on the bottom. And now I'm going to use the molar mass of the unknown substance, CO2. And I know that 1 mole of carbon dioxide is about 44.01 grams of carbon dioxide. So I take 25, I multiply it by 3. We can skip the dividing by 1. And then I multiply it by 44.01. I get 3,300 grams. And it's tough to get that into 3 sig figs. So I think you could just easily put down 3,300 and just have 2 sig figs and be okay. But our best answer would be 3.3 times 10 to the third. This would be the perfect answer. This would still be full credit. Okay, what about for D? If we have 325 moles of oxygen, how many moles of water would be produced? Now, moles to moles, this is a one-step problem. All we need are the balanced equation ratios. Notice that the balanced equation ratios are the conversion factor we will always use. So let's put the mole that we're trying to cancel on bottom. That's oxygen. Let's put what we're trying to find on top. That's the water. So we're going to do 325 times 4 divided by 5, and we get 260 moles about. And again, to get that into 3 sig figs, and then we put 2.60 times 10 to the second moles, or you just put 260 in your 1 sig fig off, and that's fine too. Okay, what about for the practice 2? So it says we have aluminum, Al, reacting with copper 2 chloride, that's CuCl2, to produce aluminum chloride, AlCl3, because it's a +3 and a -1, and copper. Okay, let's start by balancing the equation. 1 aluminum, 1 copper, good for now. 2 chlorines and 3 chlorines. So we got to start by balancing those chlorines. We now have 3 copper atoms on the reactant side, so we need 3 on the product side. And we have 2 aluminums on the product side, so we need 2 aluminums on the reactant side. Now question B says if we have 25 grams of copper, how much aluminum could be made? Now I put this problem here on purpose because I just want you to think about what the word much means. Moles is an amount, grams is an amount. For this problem, you could technically go to either. Let's try both. So let's just say we're going to moles of aluminum. So I would start by going from getting rid of my grams of copper. So 63.55 grams of copper are in 1 mole of copper. And then I would do my mole ratios. So 3 moles of copper are produced from 2 moles of aluminum. Now if we were stopping here, I think we would get 0.262 moles of aluminum. But remember, grams is also an amount. Grams is also how much is made. So we could keep on going, and we could say that 1 mole of aluminum is 26.98 grams of aluminum. And we could also answer 7.08 grams of aluminum. And for this problem, if this was a short answer, both of these would be valid answers, if you really are thinking about what an amount is. Okay, for question C, we're given 2 moles of aluminum, and we're asked for grams of copper chloride, copper 2 chloride. This is a moles to grams problem. It's going to be 2 steps. First, we're going to start out using the mole ratios, the balanced equation ratios. For every 2 moles of aluminum, it is going to react with 3 moles of copper chloride. And 1 mole of copper chloride is 134.45 grams of copper chloride. Now we get 403 grams of copper 2 chloride about. I think this answer is great. But if we're trying to use 2 sig figs, I think 4.0 times 10 to the second would be even better. Okay, I hope this helps. And if you want more practice, check out the workshops.